matrix multiplication problems here. Remember, you need to do each row times each column. Don't let this one scare you. Just take it one step at a time. All the row items times all the column items, the matching ones, and then you add their products. So let me write this one out. So we're going to get 5 times 5, negative 4 times 5, negative 5 times 2, and negative 1 times 1. And we're going to add all those multiplication problems together. We're going to get 5 times 5 plus negative 4 times 5 plus negative 5 times 2 plus negative 1 times 1. That's going to be the first item in my first matrix, and I'm going to take this one and times by the second column. You notice I'm kind of out of space here, and so I'm going to put this just over a little bit right here. So I'm going to get 5 times the negative 6 plus negative 4 times negative 4 plus negative 5 times the 2 plus negative 1 times negative 6. And that's going to be my first row, so this is the first time in the row, that's the second one. And now I'm going to take my second row and times by the first column. Again, I'm going to write it out the same way, 2 times the 5 plus 1 times the 5 plus 2 times the 2 plus 2 times the 1. And then I'm going to do the second row times the second column, scoot it over a little bit because I ran out of room. 2 times the negative 6 plus 1 times negative 4 plus 2 times, 2 times the 2 plus 2 times negative 6. And so this is my intermediate matrix. I now need to do those calculations, and it's actually going to come out to just a 2 by 2 here. And so let me do these calculations real quick. 5 times 5 is 25, negative 4 times 5 is negative 20, that's negative 10, and that's negative 1. So negative 1 plus negative 10 is negative 11, plus negative 20 is negative 31, plus 25 is going to give me just negative 6. This here is negative 30, positive 16, negative 10, and positive 6. So 16 plus 6 is going to give me positive 22. Negative 10 plus negative 30 is going to give me negative 40. So negative 40 plus 22 is negative 18. And then the next part here is going to give me 10 plus 5 plus 4 plus 2. So 4 plus 2 is 6, plus 5 is 11, plus 10 is going to give me 21. Negative 6, negative 4, positive 4, negative 12. Well, the negative 4 and the positive 12 add out to give me 0, and I'm looking at just negative 12 and negative 12 being added together, which is negative 24. And that's going to give me my resulting matrix right there. Alright, and I checked it out on the calculator. It comes out just like that. Alright, so there's that. Let's move on to 11. This is each row times each column. This one just happens to have 3 columns instead of like 2 or 1. But we're still going to use the same method. 1 times that negative 4 plus the negative 4 times the negative 2. And that's going to be my first entry. First row times second column is going to give me 1 times 0 plus negative 4 times 6. And that's going to be my second entry. And then my next one, first row times third column, is going to give me 1 times negative 3 plus negative 4 times negative 6. And there's my third entry. Now I'm going to do second row times each of these columns, just like I did on this with the first row. Negative 2 times negative 4 plus 1 times negative 2. I get negative 2 times 0 plus 1 times 6. And then I'm going to get negative 2 times negative 3 plus 1 times negative 6. And I can tell you a little secret on what I did. I just looked at this number right above it and put it there. And so all I had to do was really just copy down these two numbers on all those spots there and copy down the number right above it to fill in the blanks. So anyway, I don't know if that's going to help you, but it might. Now I'm going to do these calculations. That's negative 4, and positive 8. Negative 4 and positive 8 is going to give me positive 4. 0 and negative 24 gives me negative 24. Negative 3 and positive 24 is going to give me positive 21. Positive 8 and negative 2 makes 6. 0 and 6, when you add them, are going to give you 6. And then positive 6 and negative 6 are going to add to give you 0. And this is my resulting matrix. Yay! Moving on to 12. Again, each row times each column. Notice how it has 4 columns. I'm going to have 4 different entries going down like this on my matrix. Okay? So I'm going to do negative 3 times the negative 4, 2 times the 1. I'm going to do negative 3 times negative 4 plus 2 times the 1. And negative 3 times 5, 2 times 6. Add that up. 2 times the 6. And now I'm going to do the next one. Negative 3 times negative 1, 2 times the 3. And I'm out of room again, so I'm going to use the indented mode again, just like I did on one of the early ones. This row times this column is going to give me negative 3 times 6 plus 2 times the 3. So that's my first row. This piece should be here. And now I'm going to do my second row times all of these columns. And that's going to give me negative 4 times negative 4 plus 0. Oh, if my second one's 0, I can just have everything plus 0. I don't even have to bother multiplying by these bottom numbers here. So that's my first entry, and I'm going to have negative 4 times negative 5. And I'm going to have plus 0, which doesn't do anything. And then I'm going to have negative 4 times the negative 1. And I'm going to have negative 4 times the 6. I'll even indent it so you guys can see it. So this is my matrix as it's sitting right now. Now I just need to do the calculations. That's 12, that's 2, add that gives you 14. That's positive 15 and positive 12. When you add that, you're going to get 27. That's positive 3 and positive 6. When you add that, you'll get 9. That's negative 18 and positive 6. That'll give you negative 12. And that there is positive 16 plus 0 is positive 16. That's positive 20 plus 0. And that's positive 4 plus 0. And that's negative 24 plus 0. And this is my resulting matrix. Ta-da! Moving on to 13, each row times each column. And this one, make sure you do 6 times the 2, 4 times the negative 5. And add them. And then I'm going to move on to the next column. 6 times the negative 5 plus 4 times negative 5. And then 6 times the 4, 4 times the negative 5 again. And make sure you add them. 4 times the negative 5. And continue on to the next row here. That row times each of those columns. And I'm going to just do that. Negative 2 times the 2 plus 3 times the negative 5. Negative 2 times the negative 5 plus 3 times the negative 5. And then negative 2 times 4 plus 3 times negative 5, and now I just need to do the last row times each of the columns, adding those pieces. 5 times 2 plus negative 6 times negative 5, and then 5 times 2 plus negative 6 times negative 5, and then 5 times 4 plus negative 6 times negative 5. And that's all the calculations and stuff we need to do to get this one figured out. That's 12, that's negative 20, that gives, when you add it, gives you negative 8. That's negative 30 and negative 20, when you add that you'll get negative 50. That's 24, and that's negative 20. And so if you add that, you're going to get 24 and negative 20 combined to give you just 4. Negative 4 and negative 15, if you add that, you'll get negative 19. Positive 10 and negative 15 are going to give you negative 5. Negative 8 and negative 15 are going to give you negative 23 when you add them up. 10 and negative 30 gives you negative 20 when you add them. 10 and negative 30, wait, that shouldn't be a 2 there. This should be a negative 5. There. Alright, negative 25 and negative 30, when you add them, I'm going to give you negative 55. 20 and, man, what am I talking about? Sheesh, man. I'm messing up all over the place. Okay, let's try this again. 10 and positive 30, I'm going to add to give you 40. Negative 25 and positive 30 combined to give you 5. 20 and 30 are going to add to give you 50. And there's my resulting matrix right there. Moving on to 14, each row times each column, but unfortunately the column is 4 tall and the row is only 3 long, so there's not enough entries. This is going to be undefined. Moving on to 15, we need to give an example of 2 matrices that when you multiply the order is a little bit different. Well, let's just do something like, jeez man, you can just do a 3 by 2 and a 2 by 1 matrix. So like if we do 1, 1, 1, 2, 3, 5, and then my other matrix is just too tall, like 5 and 6. If you multiply this out, if you multiply them exactly how they are, you'll get some sort of matrix that's a 3 by 1. So it's going to be 1 tall, 1 column but 3 long. But if you switch the order, like you get 5, 6, and you try to times it by 1, 2, 1, 3, 1, 5, you actually can't do that, because that's only 1 long, and that's 3 long, so this one is undefined. So here's an example of some matrices that don't work, so you can't have commutative property here. And then on 16, the dimensions don't always have the same dimensions as the matrices you multiplied. How you can tell whether the dimensions of the answer matrix can be determined by the dimensions of the matrices being multiplied. Well, the way it works out is just this. Here, let me write it out. There we go. That way you didn't have to wait for me to write it all out. If you have 2 matrices, and the first one is like a 3 by 2, and then the other one is something like a 2 by 5, your resulting matrix is going to be a 3 by 5. So notice how those pieces kind of disappear, at least those numbers on the dimensions, and you get whatever's left over for your remaining dimensions. If you really want examples of that, you just go back throughout the assignment. This guy here is a 3 by 2, and this one is a 2 by 3, and we ended up with a 3 by 3. And this one was a 2 by 2, this one was a 2 by 5, 2 by 4, and we ended up with a 2 by 4, and that's how it is.